This lesson is on angles of elevation and depression. Our vocabulary for today is angle of elevation and angle of depression. An angle of elevation is the angle formed by a horizontal line and a line of sight to a point above the line. In the diagram, angle 1 is the angle of elevation from the tower to the plane. An angle of depression is the angle formed by a horizontal line and a line of sight to a point below the line. Angle 2 is an angle of depression from the plane to the tower. Since horizontal lines are parallel, angle 1 is congruent to angle 2 by the alternate interior angle theorem. Therefore, the angle of elevation from one point is congruent to the angle of depression from the other point. We'll be using angles of elevation and depression to solve word problems with trigonometry. We want to classify the angle as an angle of elevation or an angle of depression. Angle 1 is formed by a horizontal line and a line of sight to a point below the line, so it's an angle of depression. Angle 4 is formed by a horizontal line and a line of sight to a point above the line. It's an angle of elevation. In this diagram, we want to identify angle 5 as an angle of elevation or an angle of depression. It's formed by the horizontal line and a line of sight, so it's an angle of depression. I always think of the angle of elevation and the angle of depression as if you have a ramp. So say the angle 6 was your ramp, the part above the ramp is the angle of depression, the part that is the ramp is the angle of elevation. So 6 would be the elevation, 5 is the depression, and same with the other one. Even though 4 is going the other direction, that's still the ramp with the flat surface, so that's your angle of elevation, and angle 3 is your angle of depression. So angle 6 is the angle of elevation. Here we're going to find a distance by using the angle of elevation. The Seattle Space Needle, which is that tall building in Seattle that has the round top, casts a 67-meter shadow. If the angle of elevation from the tip of the shadow to the top of the Space Needle is 70 degrees, how tall is the Space Needle? Round to the nearest meter. So here's our picture. The shadow is on the ground, that's the 67 meters, and the angle of elevation is 70 degrees. We need to draw a sketch to represent our information, which is to the right, and we're going to let y be the height of the Space Needle because that's what we don't know. We're given a side adjacent to angle A, and y is the side opposite, so we set up a trig ratio, and in this case we're going to choose tangent because we're using opposite and adjacent. If we multiply both sides by 67, we get the following expression. Put that in your calculator, and we find that y is equal to approximately 184 meters. An ice climber stands at the end of a crevice that is 115 feet wide. The angle of depression from the edge where she stands to the bottom of the opposite side is 52 degrees. How deep is the crevice at this point? Round to the nearest foot. Go ahead and take a minute, pause your video, and try to draw a picture of what you're reading here. So our sketch looks like this. We have our angle of depression, which is 52 degrees, and y is the depth of the crevice, and the distance is 115 feet at the bottom. The alternate interior angle theorem says that measure of angle B is 52 degrees. So we set up a tangent ratio saying that tangent of 52 is y over 115. We chose tangent because we're using an opposite and an adjacent side. We multiply both sides by 115 and get the following expression. Put that in our calculator and find that y is approximately 147 feet. A pilot flying at an altitude of 12,000 feet sights two airports directly in front of him. The angle of depression to one airport is 78 and the angle of depression to the second airport is 19. What's the distance between the two airports? Round it to the nearest foot. So again, pause your video, see if you can draw your picture, and then check it once you've drawn it out, unpause and see if you can figure out if you have the right picture. So here's our sketch where we have the angle of depression is 78 and the angle of 19 for the other. So in our sketch we have P being the pilot and A, B are the two airports. X is the distance between the two, Y is between the spot directly under the pilot and the first airport, and Z is the whole distance. So now we need to find y. By the alternate interior angle theorem, measure of angle CAP is 78. In triangle APC, tangent of 78 equals 12,000 over y. Again, we're using tangent because we have an adjacent and an opposite side labeled. So y equals 12,000 over tangent of 78, which is equal to approximately 2,551 feet. Now we want to find z. The alternate interior angle theorem says that measure of angle CBP, is 19 degrees. In triangle BPC, tangent of 19 is equal to 12,000 over z. Again, we're choosing tangent because we have an adjacent and opposite side. Z is equal to 12,000 over tangent of 19 degrees, which is approximately 34,851 feet. Last, we need to find x. X is found by taking z minus y. So x is approximately 34,851 minus 2,551, which is approximately 32,300 feet. The two airports are approximately 32,300 feet apart. Here's your lesson quiz. You're going to be practicing some identifying angles of elevation and depression, as well as solving some word problems using angle of elevation and depression.